So a little refresher on our concepts here in integration by substitution. Before I go back through the rules that we developed, basically the general rule is saying, look, if you have some function in here that you're trying to integrate, all right, and it's a function of x, but we'll just put, you know, we'll just put f lowercase, and this is a u here is a function of x. Whatever the function of x is, you have to have the derivative with it in front, okay, of the inside. And then when you integrate, what happens to your u prime? This appears, and you're going to get the antiderivative of this. So it's going to be, remember, f capital is the antiderivative. Now it's plus c if I'm doing indefinite integrals. There's some definite integrals, so you just sub those numbers in. Okay? So that's just the gist of what we're doing. Okay? So this, remember, is the antiderivative of f lowercase. Okay? That's f capital. So some rules that we did. So the power rule. So we upgraded power rule to now work for any function of x to a power. Now this is where it gets tricky, because I'm going to show you how you could have where you don't think it's power rule, but it is. Okay, so how could I have some power rules? Then we've got u prime times e to the u. And I'm sorry, let me write the answer. So power rule u to the n plus 1 over n plus 1 plus c, n does not equal to -1. Here, u prime e to the u is just e to the u plus c. U prime a to the u is a to the u, remember, over ln of a. You have to divide by ln of a plus c. We won't get many of these. But this E is basically a special case for this, because if we had E, ln of E is 1. So, all right, and then you had your trig ones, right? So we had u prime cosine of u is sine u. U prime sine u is negative cosine u plus c. U prime secant squared u is tangent u plus c. I'll put the other three here. U prime cosecant squared u is negative cotangent u plus c. U prime secant u tangent u is secant u plus c. And then u prime cosecant u cotangent u is negative cosecant u plus c. All right. So those should be the rules that we had developed. There's one that we're going to save for the next section. So the next section is, if you remember this rule, the integral of 1 over x dx is ln of absolute value of x plus c. That's going to be the next section. We'll focus on that. That's in section 4.6. So we'll worry about that one. You shouldn't have any of those in this section. So I want to do a refresher of maybe a basic trig one and a basic power rule one, and then I want to show you where it can get a little bit more complex, where you may not be sure what the rule is. So a basic power rule might be something like this. All right. And again, it's just a matching, right? I mean, well, I know it's not a trig. I just know it's not e to the u. I know it's not a to the u. So the only choice it leaves me is power rule. So again, what I'm trying to make this match is u prime, some function in parentheses raised to a power. So I'm probably going to rewrite my square root to what? Half. So once you do this one, so try and do part A there, just integrate. So we're just going to integrate these. And then just a basic trig one. So let's just say you've got cosine of 7x. Now remember, you have to make sure you have what in front. What has to be in front? what has to be at the front here, and what has to be at the front here. It's in your rules. U prime. If you're off by a constant, so this is what I taught you, I know it's been it feels like 2 weeks ago. But remember, if you're off by a constant, you put that constant there, and you put what on the outside? Because you gotta balance it.
1 over.
Yeah, 1 over. So if you put a 2 here, you gotta put a half out there. You put a 5 here, you gotta put a 1/5. So just see if you can remember how to work these using your rules. So you've got to make sure that these both match up to, that should match up to power rule, this should match up to U prime cosine U. Take a quick second, see if you can work those. And I don't think you're getting any rules outside of these. Just the only ones I need to show you are the tricky. The ones that you may not know which rule to use. So if I go to the part A, I see, okay, this is a power rule because I'm gonna change my square root to the 1/2. And so it's just about getting it to match to the template, okay? So I need U prime in front. What is U prime for this problem? Well, more than X, it should be what? Yeah, since this is X squared plus 7, the derivative of the inside is 2X. So I need to put a 2 there, but at the same time, I can't just throw a 2 in my problem. So I'll put a 1/2. So remember, I said you can always multiply by 1 in math, and it still stays equivalent. So that 1/2 will remain part of our answer. The 2X, remember what happens when you integrate, you lose the U prime. And then now I just have to apply a power rule. So I add 1 to the exponent, which will make my exponent what? 3/2, and then divide by 3/2. Put a plus C. But what happens, this 1/2 in front will cancel with this 3/2 on the bottom, because if you move this 2 down here, see, or you could just flip this and multiply, make this a 2/3. Either way, these 2's cancel, and that's your final answer, X squared plus 7 to the 3/2 over 3 plus C. Oops. Okay. Okay. Then go into the trig one. So it's cosine of 7x. I need what in front? 7. Okay, because it's, again, I'm just trying to match it to this template. So I'll put a 7, but once I put a 7, I put what else? 1/7. So again, the 1/7 will multiply to my answer. This 7 disappears, and now it's just what's the antiderivative of cosine. So I go to our rules, the antiderivative of cosine is sine of 7x plus c, and that's it. as the answer. Okay? This is a little review of what we did a couple of weeks ago. So those are pretty straightforward, all right? Your job is to see, well, if I don't have u prime, can I make a u prime, right? How do I get that? And you should only be off by a constant. Now where it gets tricky, so I'm just gonna need to erase these two here so I can show you one that I think is a little tricky, right? So where it could get tricky is something like this. The question's gonna be, well, how do I work this? You know, a couple of these where, what's the rule I'm gonna use if I'm, you know, not sure what it matches to. So we'll call this example 2, just still we're integrating, but we may have some tricky problems now. So something like this. All right. Notice once you see the secants and tangents, now your eyes need to go to the trig ones. But if you look at this, do any of your trig rules have a secant squared and a tangent cubed in it? No. So now we have a little bit of a problem. It's not going to match any of these, right? These are literal. For it to be this one, it has to be secant u, tangent u. So your eyes may go here, you may think, oh, it's this one somehow. Well, it's not. I can tell you this, it's none of these. It is not a trig integral. Okay? So the hardest thing for you to understand is that this is not one of the 6 trig ones. It is one of the rules, but it's not one of the 6 trig. So you just got to let go of that because it's this guy that we have a problem with. If we didn't have this, then does it match to one of the rules? Yeah, matches the secant squared, right? So now the question is going to be, well, what can it be? All right, so if I've at least told you, eliminate those 6, now you have only 3 choices left. So if I'm giving you a hint that it's none of these, and you have only 3 choices left, which one does it have to be? It has to be power rule. This is the only one that it can be. And notice here's what's tricky. U is a function of x. Didn't say it could be a trig function. Okay? So here's how I do this. I cover one of the numbers up and I ask myself, if I take the derivative of this piece, just cover the exponent, do I get this one? So if I take the derivative of secant, will I get tangent cubed? Is the derivative of secant tangent cubed? No. Okay? Then go over here, cover up the 3. You'll see why I'm doing this in a second. Is the derivative of tangent secant squared? Yes. Now that's important to understand. So what I'm trying to look at is change it instead of to a cube like that. That means the same thing as tangent of x quantity cubed. Okay? So why did I rearrange it like this? Because now it fits power rule perfectly. This is a power rule problem. If I look at power rule, what does it say? I have to have u prime u to the n. There's nothing for me to do. What's my u? My u is tangent, okay? What's u prime? Derivative of tangent is what? Secant squared. It matches it perfectly. It is already set up. It's a power rule. So then all I have to do is just apply power rule. Well, this is the hardest part because students feel like, well, it's got trig stuff. Shouldn't I be using, like, isn't it the answer just like secant or something? No. What does power rule say? You take your u, you do what to the exponent? Raise it by 1, so I'll put it to the 4th and divide by 4 plus c, done. That's it. Okay. I'll show you another one. So how do I know to use power rule? It's just process of elimination. Okay. So what made me go to power rule? Because it doesn't fit any of these. This is literal. That's the beauty of calculus. It literally must be just secant times just tangent. okay? If it's not just secant times just tangent, then I can't do that, all right? Okay, so another example. And let me also, yeah, let's keep it simple for now. It's just because it can get a little meatier. I'll do one in a second. All right, so we look and we say, yeah, none of my trig rules have a fraction in it. All right, so again, my hint is going to be to you is this. If you see that it does not match any of the trig ones perfectly, but it has two different trig guys and one has an exponent, that's probably your u here. See, this is probably your u to the n. So the first thing is I'm going to bring this up because if I'm going to try power rule, they got to be next to each other, not below. So how do I move this one up to the top? Make the exponent negative. So I'll write it sine x times cosine of x to the negative 4th. And now I'm going to draw it right below and see, does this match u prime u to the n? Almost. Almost matches it. Okay? So what's tricky are these power rules with trig functions. That are what I think are the toughest problems in this section. Is to understand that it's not a trig rule, it's a power rule. So what am I lacking? What am I missing?
Yeah, negative.
A negative, because if your u is cosine, then the derivative of cosine should be negative sine. But if I'm off by a negative, can we handle that? Yeah, and if it helps you, look, if you want to drop below and put u is cosine x, u prime is negative sine x. If that helps you, then do it. I mean, I just, for so long, I just do it in my head, right? But as long as you understand that you've got to, that this has to match to this template. As long as you've got that, then that's all that you need to know there. All right, so I need a negative there. So what goes in front? Another negative. Now remember, this is just power rule. So to get my answer, it's going to be negative times this. Just go ahead and answer it. I know who it is, don't worry. This right here just disappears, okay? So that we don't worry about, okay? Then what happens with this piece? What will we do with this? By power rule. So it'd be cosine of x to the what? To the negative 3, and then just divide by negative 3 plus c. And then those two negatives should cancel, and then I would probably clean this up. I always say it's taboo to leave a negative exponent with my answer. So the last thing I would do is make this 1 over 3, and I'd make it cosine cubed x plus c. There you go. I think about it. We're working back. We're trying to think, what function can you take the derivative of and get that? I mean, that's not pretty clear there, okay? All right. So this gives us a process to get this function. Okay. So I hope at least that helps you a little bit to get you to be aware that you might have some power rules with these trig functions here, okay? All right. So now, I'm going to erase this so we have room. Real quick. Next example, find the particular solution. So let's say we have dy over dx equals e to the 5x at the point 0, 1, okay? All right, so remember this is a differential equation, but we're gonna need what we're learning here to also now go back to how we would solve differential equations. So remember, what we're looking for is the original function. We're looking for y equals what, and then you're gonna get a plus c, but this point allows us to solve for our plus c, because we know a point on the function. So that's how we're gonna get a particular solution. So let's go through the steps and kind of remember how to do this. If I'm gonna solve and try to find y, what do I do with the dx? So anytime you're solving differential equation, dy over dx, your first step, multiply the dx over here. Because you got to have that dx, because then the next step is going to be our integrals. All right, so the dx has to be in here so I can integrate. Then next step, you put your integral symbol on the left and on the right. This is just solving differential equation. This was back earlier in chapter 4. Now, what's the antiderivative of 1 with respect to y? Y. The left is always just your y. That's where you get your function. Don't worry about that plus. Don't put a plus c and a plus c here. Just wait to the end and put 1 plus c at the end. But now you got to take what we've been doing and figure out how to integrate this. So the left-hand side becomes y. Now, how do I get the right-hand side? Now you take what you've learned, get that answer, then plug in your point. When x is 0, y is 1, and that allows you to solve for c. So see if you can finish this on your own. But I just want you to see how we tie in what we've been doing with power rule and the differential equations. We'll stop here and let you get to work in the assignment today. We'll work tomorrow, but we'll probably pick some of the tougher problems and put them on the film. Okay. So what are we missing? What needs to be in front of this? A 5. So we need a 5. We put a 5, but we also put what in front? 1/5. So that 1/5 is part of our answer. This 5 disappears, and then it's just e to the 5x plus c. And then from here it becomes a fairly simple problem, because now I just have to solve for c. So all I'm going to do, y is 1 when x is 0. Now, so this is where we're figuring out what's the actual curve. So we won't have a plus c now in our answer. Now, e to the 5 times 0 is just e to the 0. So what's any base to the 0 power other than 0? But what's e to the 5 to the 0, 4 to the 0, e to the 0 is always what? 1. You get 1 equals 1/5 plus c. Well, let's see. You don't even need to worry about, just think in your head. 1/5 plus how many fifths is going to give you 1? So c has to be what? 4/5. Okay? And there you go. And now you have your particular solution. So you take your answer that you got, 1/5 e to the 5x, that's your antiderivative, and now we solve for c, which is 4/5, and that is the particular solution. And that's tying in old of solving differential equation, which we did a little bit of that, with the new of having to use this power. Now, what's the only thing that I'm not, doing a lot of? Well, like let's say we had, let's go 0 to pi over 2. I gotta make sure I can do this one. Always. Yeah, let's just make it simple. I'll probably get myself in trouble if you'll see what I mean. Let's do, can't just make these up. But like, if you get limits, right? So, doesn't matter, this is fine. There, this will be fine. Okay. If you have limits, nothing changes. You just put the limits in at the end. Limits, I'm talking not, these are upper limit, lower limit, boundaries, definite interval. So you would still do your normal integration. This may not be a bad one to just look at real quick for a refresher. So what am I missing in order to integrate? What needs to be there? U prime. What's U prime going to be? 2. So we need a 2. I'm just throwing another, just call this example 4. So, but once I put a 2, I must put what in front? 1/2, okay. So what is the antiderivative of cosine? Sine, right? Sine of 2x. But now I have to put my limits. So what's going to happen when these limits go in? I'm going to do 2 times whatever these are. So it'd be a good reminder that at quadrant angles, 0, pi over 2, pi, that we use the point on the unit circle to evaluate. So again, we've refreshed you on this several times, that the cosine of the angle is the x and sine of the angle is the y. So if you wanted cosine of pi over 2, it would be 0, sine of pi over 2 is 1. If you want cosine of pi, it's -1, sine of pi is 0. It's always in that order. Cosine of the angle is always the x coordinate, sine of the angle is always the y. So if I sub in my limit, it's going to be 1/2 sine of 2 times pi over 2 minus 1/2 sine of 2 times 0. So let's go one at a time. 2 times pi over 2 reduces to just pi. So sine of pi, I go to the unit circle, angle pi is here. Sine is always the what coordinate? Y. So it's what? 0, that's gone. Whoops. Not much to do here. You'll see why, if you were to look at area, it's the same piece above and same piece below, it cancels out. All right, sine of 0, what's sine of 0? 0. So the answer is 0. Now you found what? That should represent net area. So your areas canceled each other out. So if you have limits, you still got to do your rule, and then you plug your limits in. This graph looks something like this. If it's cosine of 2x from 0 to pi over 2, it looks like this. See, so you can see why the answer is 0. Areas cancel. Okay, we'll stop there for today. So that gives us a bit of a